So far, in describing motion of objects, we ignored one very important force, that is the force of friction that exists between surfaces. If you look at motion all around us, most of these motion occurs one surface relative to another. That means an object is moving on a surface, which obviously brings in the force of friction between surfaces. So this is a force we cannot ignore. In this lesson, we will look at the force of friction between moving surfaces. Well, I have set up a simple surface. I'm going to make it move on the desktop. And in order to move, I need to apply force. And I have a scale that will measure that force in Newton. Can you read this? This is 0, 1, 2, 3, and so on. And watch me apply a force. And if you notice, I'm actually applying a force now. A force of 1 Newton. Why isn't the surface moving? Why isn't the block of wood moving? Because the friction is opposing the applied force. The friction is opposing motion. I'm going to increase the applied force to 2 Newton, to 3 Newton. You see, it's still not moving. So what does that mean? It means as you increase the applied force, the friction also increases. Well, let me increase the applied force to 3 Newton, to 4 Newton. Well, I have now broken the friction. Now, what that means is, as you increase the applied force, the frictional force between the two surfaces will increase. But the frictional force cannot keep on increasing. There is a limit. The maximum frictional force between two surfaces is called the force of limiting friction. I will write down that on the board later, but let's do some discussions first. So what is the force of limiting friction? A force of limiting friction is the maximum frictional force that exists between two surfaces. Well, tell me, what is the reason for frictional force? I have a block of wood here, and the block of wood is to be made to move on the surface of the table. What is it that causes the frictional force? Well, the frictional force is actually caused by various reasons. The simplest explanation probably is the interlocking of the minute infractions, let us say, because if you look at the surface of any object, although it looks smooth, there are ups and downs on any surface. So when you keep one surface on top of another, there will be interlockings of these imperfections. And in order to move one surface over the other, you need to overcome that. Now tell me, what is the factor on which the force of limiting friction depends on? Well, if you can increase that interlocking, in other words, if I can increase the normal force, then I would expect the frictional force will be greater. Is that right? If I press harder on the block of wood, it will be difficult to move it. All right, let's have a look at that one more time. Now, when I increase the applied force, now I had some masses kept over here. When I increase the applied force, can you read the force there? The frictional force increases, and there you are, about 4 Newton. I need about 4 Newton force to overcome the friction. That means the force of limiting friction in this case is about 4 Newton. Now, I'm going to put another mass on top of this block. What does that do? that will increase the normal force. In other words, that will increase the force pressing this block onto the table. And now you watch what happens. Well, I'm actually crossed 5 Newton. Yes, I need about 5 Newton to move this now. The force of static friction is now 5 Newton. Now, I'm going to increase the normal force by putting more weight. I can see now, well, I need a lot of force. There, I needed about 8 Newton to set it in motion. That means as the normal force, the force pressing the two surfaces increases, the force of limiting friction also increases. So if I ask you, what is the factor on which the force of limiting friction depend on? Well, one answer is the force of limiting friction depends on the force that presses the two surfaces together, which we call the normal force. And what is the normal force in this case? It is the weight of this block, the total weight, or the normal force equal to mg when the two surfaces are horizontal. Okay, let's put this thing. So, what is force of friction? Friction is a force that always opposes motion. A box of mass m placed on a surface A and a force, an applied force F tends to move it. The applied force F wants to move it to the right. Now what happens? The frictional force F between these surfaces will oppose the motion, will be acting in the opposite direction. And we will represent frictional force by the lowercase f. Now, if the applied force F is not sufficient to overcome this frictional force, then the box will not move. As the applied force increases, the frictional force also will increase until it reaches a maximum value. And what did we say that maximum frictional force between two surfaces is called? It is called the force of limiting friction. The maximum force of friction between two surfaces is called the force of limiting friction, and we will represent that with the lowercase f. Now, so whenever we talk of friction between two surfaces, we actually mean the force of limiting friction, and that will be our lowercase f. Now, what are the factors that affect the force of limiting friction between the two surfaces? I just illustrated that to you here. What is the one factor that affects the force of limiting friction? The one factor that affects the force of limiting friction is the force that presses the two surfaces together. In other words, it is the normal force. And when the two surfaces are horizontal, the normal force is the weight of the object that is being put in motion. The only factor that affects the force of limiting friction is the normal force, that is the force that presses the two surfaces together. Now, we have talked about this normal force several times. When the two surfaces are horizontal, the normal force is equal to mg, the weight. Now, do you remember, if an object is placed on an inclined plane, well, when the object is placed on an inclined plane like this, what is the normal force in such a case? Anybody remember that equation that we developed? When the block of wood is on an inclined plane, there you are. What is the normal force pressing the wood onto the surface? will be mg cos theta. Is that right? Yes. We will be looking at that as we move on. So whatever the normal force is, the force of limiting friction will depend only on the force of normal, the normal force between the two surfaces. Well, of course, it depends on the nature of the surface. We are talking about for given two surfaces, the force of limiting friction depends only on the normal force. Now, let's now talk about the concept of coefficient of limiting friction. Coefficient of limiting friction. Well, this can be obtained, or this concept can be explained by the fact that the frictional force is directly proportional to the normal force. You increase the normal force, you increase the friction. So, what is the normal force that is pressing the two surfaces together here? The two surfaces are horizontal, therefore the normal force is the weight mg of the box that is acting down. Well, mg is acting down and the surface will apply a force F sub n upward, and this is the normal force pressing the two surfaces together, and this Fn equal to mg. Is that right? The normal force equal to mg, and it is that normal force that presses the two surfaces together. That means we can now make a statement which can be called the law of friction. What does that say? The force of limiting friction, lowercase f, is proportional to the normal force Fn. Can you write that down using your mathematical notation? Lowercase f is proportional to the normal force. We write it like this. F is proportional to Fn. And a statement like this, you know, can be written as an equation. Now, what will be that equation? The proportional sign can be replaced by an equal sign. Alright, so F is proportional to Fn can be written as F equal to a constant multiplied by Fn, and this constant is what we call the coefficient of friction between the two surfaces. Alright. Now, because Fn equal to mg, we can now write this as the force of limiting friction equal to mu times mg. The force of limiting friction between two surfaces that are horizontal with respect to each other will be equal to mu times mg. A very important relation. That means mu can be calculated as the force of limiting friction divided by mg. Okay. Let's now talk about kinetic and static friction. Well, let me demonstrate that again one more time. I'm going to show you how we can measure the coefficient of friction between the two surfaces, and then I will explain the difference between kinetic and static friction. Well, now you know that the force of limiting friction between two surfaces equal to mu times mg, where mu is the coefficient of friction between the two surfaces, m is the mass, and of course mg is the weight of this system. Now, let's measure the force of limiting friction, and what all I need to do is slowly, there you are. How many? Let's go. 0, 1, 2, 3, 4, 4.5. I needed 5 Newton to make the system move. So I got the force of limiting friction is 5 Newton. And what is the total mass? I measured the mass of this piece of wood, that is 230 gram, and this is a kilogram. That is 1230 gram, 1.23 kilogram. And what is mg equal to? So I will be able to say mu equal to 5 Newton divided by mg is 1.23 multiplied by 9.8. Now, can you calculate that for me? Mu is 5 Newton divided by 1.23 times 9.8. That will be 5 divided by 1.23 times 9.8. I got this as 0.4. Now, tell me, what is the unit of this coefficient of friction? What is the unit for measuring the coefficient of friction? The force of limiting friction is measured in Newton. Weight of the block is measured in Newton. Therefore, coefficient of friction has no unit. Now tell me, if I now increase the weight, will the coefficient of friction change? I now need a greater force to move the system. Well, I now need 5, 6, 7 newtons. Well, because the force of static friction is directly proportional to the normal force, increasing the weight will not change the coefficient of friction. Because you increase the weight, the force of static friction also will increase. The coefficient of static friction is a constant for two given surfaces. Alright, now let's talk about the distinction between static friction and kinetic friction. Well, now watch this. When I want to move this, there is no relative motion between the block of wood and the table. Now, the force of friction, the maximum force of friction now is called static friction. But, now watch when I make it move. Now, how much force I need to apply to make it move? I need about 7 Newton. And watch now, to keep it moving, I need only 5 Newton. So, one more time. Watch that carefully. In order to set it in motion, in order to begin the motion, in order to break the force between the two surfaces, the maximum frictional force is 7 Newton. And you notice that the moment it begins to move, the scale shows a lower reading. Now, that's the maximum. The moment it moves, what's that? Alright, the moment it moves, you need only a less amount of force to keep it moving. What does that mean? It means the maximum frictional force between two surfaces that are at rest with respect to each other is greater than the force of friction when the two surfaces are in relative motion. But that can be understood, is that right? Because when they are in motion, the imperfections are sort of overcome. So you need only lesser amount of force to keep it moving. Now, the force of friction, the limiting friction between two surfaces that are at rest relative to each other is called the force of static friction. We say the limiting friction is the force of static friction. And we will represent the force of static friction by F sub S. On the other hand, the frictional force between two surfaces when they are in relative motion is called the force of kinetic friction, and we will represent it by F sub K. So I hope this is now clear. In order to set an object in motion, you need to overcome the force of static friction that is much greater. Now this is now the force of static friction. The moment it moves, you can see the scale reads less amount. So the force of kinetic friction is less than the force of static friction. Now, if that is the case, you can see mu is force of limiting friction divided by the normal force. That means the force of static friction can now be written as that means this mu has different values for static and kinetic, depending on whether you use the static frictional force or kinetic frictional force. So I can say mu equal to, if I use Fs, I'm going to call that mu s. Mu s equal to Fs over mg. Similarly, mu k equal to Fk over mg. So we will be using two types of coefficients of friction. Mu s represents the coefficient of static friction, and that will be the force of limiting friction when it is static. The force of static limiting friction divided by mg, and mu k is the coefficient of kinetic friction, that is Fk over mg, where Fk is the force of limiting friction when the two surfaces are in relative motion. Well, now tell me, when you drive on the road, what is it that makes your car roll on the road? Well, the force that makes your car, the wheels of the car roll is the force of friction between the tires and the road. Now, that can be understood if you go to Buffalo now and try to drive on the roads there. They're all slippery and the friction is very, very small. That means if you try to put your foot down on the accelerator, the wheels will rotate, but the wheel will not roll. In order to make the wheel roll, you need friction between the tires and the road. Alright, the question is the friction between the tires and the road, is it static friction or kinetic friction? What do you think? Well, I know most of you will be tempted to say it is kinetic friction. Is that kinetic friction? No. You see, when the wheel begins to rotate, a point on the wheel, at any instant, it is a point on the wheel that is in contact with the road. And the friction between the tire and the road at that time is the force of static friction. It is not the force of kinetic friction. Now, when does it become kinetic friction? When your wheels lock and the wheel begin to slip. That is when the force of kinetic friction sets in. And that is the reason why many cars these days come with anti-lock brakes. So when you brake, your brake should not lock. The moment the brake locks, your tires will cease to rotate. And from then on, your tires will slip. And the friction between the road and the tire at that time is the force of kinetic friction, which is less than the force of static friction. And that is the reason why when your car begins to slid, you lose control, because the force of friction is very small. So when you brake your car, you need to bring your car to a stop in a controlled manner. The wheel should continue to rotate so that the force of friction between the road and the tire is always the force of static friction. Alright? So I hope you understand the difference between the force of kinetic friction and the force of static friction. Alright. Now once you are able to overcome the friction between two surfaces, then one surface will begin to move over the other. If the applied force F is greater than the force of limiting friction, the box will move. Once the box is in motion, the two surfaces are no longer pressing together as tight as before, so the force of friction therefore decreases. When the box is in motion, the force of friction between the two surfaces is less than the force of limiting friction before they started moving. And therefore, the force of friction between two surfaces at rest relative to each other is called the force of static friction, and we will write it as F sub S. And the force of friction between two surfaces that are in relative motion is called the force of kinetic friction, and we will use F sub K to represent that. Well, you know that the force of kinetic friction is less than the force of static friction. And Fs can be written as mu s times Fn, is that right? Where mu s is called the coefficient of static friction. And what will be the equation then for Fk? Fk will be mu k Fn, where mu k is the coefficient of kinetic friction. Now, which of these is greater? Mu s is greater than mu k, or mu k is less than mu s. Mu k is less than mu s. Where this is the case, when the two surfaces are moving on a horizontal level. Now what happens if you now place this box on an inclined plane? Alright, let's look at that now. If the box is now placed on an inclined plane of inclination theta, what will be the normal force on the box? We talked about it in the beginning. You know, when an object is placed on an inclined plane, its weight mg will be acting vertically down. That mg is no longer the normal force. The normal force, or the force pressing the two surfaces, will now be mg cos theta. That is the normal force now. So only that force comes into play when you talk about the friction between these two surfaces. The weight of the box mg acts vertically down. There you are, that is mg. And the component of mg pulling the box down the plane is mg sin theta. mg sin theta pulls the box down the plane. And the component of mg pressing the two surfaces together is mg cos theta. And this is the normal force. The normal force between the two surfaces Fn equal to mg cos theta. So wherever we use Fn so far, we need to replace that Fn by mg cos theta. Alright, that means the equation for the force static friction in the case of an inclined plane becomes mu s equal to mu s Fn, and that Fn in this case now is mg cos theta. So you must be able to now distinguish here the force static friction between two surfaces that are inclined at an angle theta to the horizontal is mu s mg cos theta. There you are. Fs is mu s mg cos theta, and it is this force that will oppose the motion. Now, this is something that you must be able to recall in solving problems. What does mu s mg cos theta represent? The force of static friction between two surfaces that are inclined at an angle theta with the horizontal. If you now want to move this object up, well, remember, the frictional force always opposes motion. If the object is trying to move down, the frictional force will be acting up. If you want to pull the object up the inclined plane, what will be the direction in which that frictional force will be acting? It will be acting downward, because friction always opposes motion. Well, if the block is now moving on the inclined plane, the force of friction will no longer be the force of static friction, it will be the force of kinetic friction. And Fk equal to mu k mg cos theta. Well, mg sin theta pulls the box down the plane, and Fs equal to mu s mg cos theta opposes it. Now, what happens when you increase the angle of inclination? Well, will Fs increase? No. Fs, the force of static friction, will not increase, will it? That's a limiting force. But as theta increases, mg sin theta will increase. And a time will come that a particular angle that mg sin theta will be exactly equal to Fs, which is mu mg cos theta. And at that time, there will be no net force on the box. That means the box can either move, the box can now move without an acceleration. If the inclination theta is increased gradually, mg sin theta increases, and for a certain angle, mg sin theta will be, that is, the force acting down the plane, will be exactly equal to mu s mg cos theta. Now, can you use these equations to obtain an expression for mu s, the coefficient of static friction? You can see mg and mg will cancel from either side. And if you divide now both sides by cos theta, look at this. Mu s equal to mg sin theta divided by mg cos theta. Mg and mg will go. Sin theta divided by cos theta is tan theta. That's right. So, if you want to find the coefficient of static friction between the two surfaces, all you need to do is keep on increasing the angle of inclination until the block just begins to break loose. That means the downward force just balances the frictional force opposing motion. And at that particular angle, this is the condition. At that particular angle, mg sin theta will be equal to mu s mg cos theta. And then at that particular angle, mu s will be equal to tan theta. Well, that is a very important concept. So under this condition, there is no net force acting on that block. Well, let's see if I can show that to you. Well, here I have now that block of wood on an inclined plane, and watch as I increase the angle of inclination. Now tell me, what are the forces now? The weight mg will be acting vertically down, And what is the normal force pressing the two surfaces together? That will be mg cos theta. And what is the force pulling the block down the plane? Will be mg sin theta. Now, at the moment, mg sin theta is not sufficient to overcome the friction. But you can see as I increase the angle of inclination, there you are, it just begins to break loose. There you are. Yes. That means this angle, at this particular angle, the mg sin theta acting down the plane will be equal to the frictional force. What is the frictional force of the plane? Fs is mu s mg cos theta. And at this particular instant, those two forces are balanced. That means if I can now measure this angle, which I can measure here, it is actually 15 degrees. So the coefficient of static friction between this block and the inclined plane is tan of 15 degrees, and tangent of 15 degrees is 0.26, I think. Yes, approximately 0.26. The coefficient of friction between these two surfaces is 0.6. Now, let me ask you, if I now keep some weights on this, will the angle change? Will the angle at which the forces are balanced change? Let's try. Well, that is 12 degrees, 13 degrees, 14 degrees. Well, 15 degrees it begins to move. In other words, the amount of weight on this will not affect it. Can you tell me why? Because when we wrote down the equation, do you remember we cancelled mg on the numerator and mg on the denominator? In other words, the coefficient of friction between the two surfaces does not depend on the weight of the block. So, it only depends on the normal force. And you can see as you increase the weight and the normal force will increase, but as the normal force increases, the force pulling it down the plane will also increase. The ratio will remain a constant. Okay, what I'm going to do is I'm going to stop this part of the lesson here. We are going to use all these concepts we developed in the next part, you know how to solve problems. Alright, I will see you for that in a while.